ways in which liquid hydrogen will create substance the ways by which we develop.
Welcome to another interview on EnergyNews.biz. My guest today is the CEO of Sapphire Technologies, Freddie Sarhan. He brings a wealth of experience across various markets. He's fostered key partnerships, launched new products, and overseen strategic acquisitions, all while excelling in both short and long cycle business environments. Freddie, welcome.
Thank you, Arnes. Happy to be here.
Can you give me a short introduction to Sapphire Technologies?
Absolutely. So we launched Sapphire Technologies in 2021. It was a startup, small team, but we believed in the technology, and we are based in Los Angeles, California. A very technology-focused team with a lot of expertise in energy and turbo machinery. So we came together, developed this technology, and then went out and launched a Series A funding round so that we could partner with some strategic investors to scale our business. And at that time, we brought in Chevron Tech Ventures and Equinor Ventures and Cooper & Company as investors in our business to help us on the journey of scaling the technology globally.
Can you describe your solution's hydrogen applications?
Absolutely. I'll start with gas in general, because that is how we launched the product. So a turbo expander harnesses wasted pressure energy that is in a flow of gas, whether it be natural gas, compressed air, nitrogen, or hydrogen. And that delta pressure across our machine is what drives a radial turbine. And in our case, that radial turbine and the coupled generator are all levitated in a magnetic field. So it spins a shaft. That shaft produces electricity in the generator, and then that electricity is converted to usable electricity by our end users, or it's able to be sold to the grid. So in the case of natural gas, we have several installations where we harness this otherwise wasted pressure energy, what would normally be going through a regulator or a valve, and take that same pressure drop across our equipment to drive a generator, produce electricity with no carbon footprint. Okay, so there is no emissions, same number of molecules on the inlet as there are on the outlet. We don't consume the gas, we just harness the wasted energy in that gas stream. In the case of hydrogen, turbo expanders are used today for hydrogen liquefaction. That's one application where, since we're harnessing this wasted energy, there is a temperature change across our machine. And if you can get hydrogen below its liquefaction point, obviously it condenses and turns into a liquid state. So today that's already happening. What we've done is we've really taken that wasted energy, and instead of just using it for the purpose of liquefaction, we are using we're gaining electricity as a byproduct. So you still liquefy because the temperature is coming down, but we can extract the electricity on top of that. So in general, the hydrogen process is not yet a very efficient process, whether it's to produce hydrogen or to liquefy it. This would help improve the overall efficiency of the entire life cycle of the hydrogen system by producing sellable or usable electricity from the liquefaction process itself. The other thing is as hydrogen grows, as the hydrogen economy grows and becomes more like natural gas, where you have pipelines and an infrastructure that distributes hydrogen in gaseous form, then we can use our technology in exactly the same way we're using it today. Every time there's a pressure regulator or a pressure drop, we can install our equipment and produce electricity, making the overall infrastructure more efficient.
How scalable is it?
So currently we have installations from 1 unit, and for us, 1 unit is we have 2 models, 125 kilowatt and a 300 kilowatt. So relatively small from a power gen standpoint. But this comes in a very, very small footprint. So our unit is a little over 5 feet long, a little over 2 feet in diameter, and that can produce 300 kilowatts. So the power density is very, very high. But in general, 300 kilowatts is not something you're going to power a city with, right? It's still a very distributed generation range. So our small scale applications are 1 unit. Our larger scale applications are 8, 12, 16 units, something in that order of magnitude. So very scalable in the sense that we can put multiple units at a location and produce energy by adding them on as building blocks. That helps several things. One, we've seen that it's more cost effective to use our technology than to custom engineer a large project at the site. And two, it increases the reliability of the overall system. If you have any issue that happens on site, it's 1 out of 16 units that goes down, not an entire custom engineered plant would have to be taken offline. So very scalable in that sense, but we're really not targeting, the gigawatt scale power plants. We're looking at things more in the single digit megawatt plants.
So actually, who are you targeting within the supply chain? That would be very interesting to know.
Sure. So again, I'll start with natural gas, where we've deployed systems, where we've produced systems. We are really looking at targeting the entire value chain from when the gas molecule comes out of the ground, so at the wellhead. Okay, so decarbonizing the wellhead is a mission of our company. There is a choke usually at the well that's holding back the pressure in the well, and there's a significant pressure drop across that choke. If we install our equipment in parallel to that pressure reduction, we can produce electricity at the well using the otherwise wasted energy and power the entire drilling process or production process. So that's kind of the first step as the molecules are coming out of the ground. The next step is gas processing and midstream. So again, you just continue to move closer and closer to the end user. We've already sold and manufactured units into that sector. And then as you start distributing it in distribution markets, so this is coming into large cities or towns. These are LDCs, local distribution companies. And these are folks that have city gate stations where they take gas from the midstream, which is a higher pressure, and they drop it to a more usable pressure for direct consumption by an end user. So think a factory or a power plant, or for a city for heating and other processes used within a populated area. So a city gate station or a governor station. So if you look at that network, that goes from the wellhead all the way to the end user, and we would pretty much stop at that city gate. After that, the pressure cuts that happen at your home are usually too small to harness much energy. So we pretty much stop it at that level. And then the other thing we're trying to do is do exactly that same thing around the world. So in some parts of the world, there's more focus on wellhead and production. Other parts of the world, like North America, you have a very mature midstream infrastructure. You have places in Japan that are gasifying LNG that they purchase, right? So they buy it by ship, they unload it, and then they gasify it. We have 2 systems running in Japan right now that I believe are over 9,000 hours operating at a regasification station. So they take the liquid, they regasify it, and they drop the pressure to feed an off-taker right outside their LNG terminal station. So those are the things that we're looking at in the natural gas space. As I mentioned, in hydrogen, we are looking at hydrogen liquefaction at a smaller scale. We're looking at process gas and refineries that are hydrogen rich. And we're looking at hydrogen distribution that would mimic what's happening in natural gas. So as we start blending hydrogen into natural gas pipelines, our equipment would be applicable. And then if it moves completely to hydrogen, then our equipment would perform the same exact way that I just described for natural gas.
What specific benefits can companies expect from implementing Sapphire Technologies' energy recovery systems, such as improved plant efficiency, productivity improvement, carbon emissions reduction, and offsetting electrical costs?
Well, I think you've named a few. I think all companies today have ESG goals. I think as a planet, as humanity, we have a responsibility to the planet. We have a responsibility to do whatever we can. And this is an additive technology, right? I'm not sitting here saying you should use Sapphire's product and not solar panels or not wind farms. It's really additive. I think we should do it all. And this enables our customers who are already flowing processed gas, natural gas, hydrogen. They're already doing this and they're putting it through a regulator because their needs are a lower pressure. And we've found a way to take that waste, produce clean electricity, and improve the overall efficiency of whatever they're doing, right? Whether it's a power plant or it's distribution in a city or it's a process that's using that gas, there's an efficiency improvement, there's a financial payback, and we're helping save the planet.
Can you explain the equivalent CO2 offset and oil consumption reduction?
Absolutely. So each one of our systems, we're estimating, has about a 2,000 ton of CO2 equivalent offset. The way we calculate that is since we're producing 300 kilowatts of electricity without any hydrocarbon combustion, without any emissions, we're saying, okay, if we were to buy that from the grid, and the grid is composed of hydrocarbon-based electricity, this is how many tons of CO2 we would be offsetting by producing clean electricity. The same calculation that you would make with a solar panel or with a wind turbine. So it's quite a rudimentary, quite a simple calculation. And the number could be 1,800 or 2,100. I mean, we can look at different metrics of that, but that's a ballpark of how much CO2 equivalent we offset per unit sold.
How does your technology contribute to global decarbonization efforts?
So as I mentioned, there are many renewable and clean energy technologies that are developing around the world. We are another one of those. And the nice thing about ours is that there is a strong financial payback. There is a fit into an infrastructure that already exists. So a lot of the emissions and a lot of the environmental focus is oil and gas companies, energy companies, folks that are burning gas to produce electricity, folks that are distributing gas, folks that are pulling oil out of the ground. I don't believe that's going to go away. I believe natural gas has a place in our future. But if we can make that infrastructure more efficient and cleaner using the exact same infrastructure and gas, I believe we're helping all of those companies do their part in decarbonization. And again, this is not something like an EV where the consumer at home is going to buy one, but this is something where if you look at a very large scale, power generation is one of the largest natural gas consumers in the world. If we can help improve that, increase the efficiency of that process, and harness an otherwise wasted energy source, why wouldn't we?
Absolutely. You mentioned Japan. What other examples of successful energy recovery projects have Sapphire Technologies developed?
We have manufactured systems here in the United States for midstream company for Tallgrass. I believe we press released that, so that's public domain, and it's a significant opportunity here in the United States for a company like Tallgrass to decarbonize their network of midstream gas pipelines that travel across the United States. We've identified many locations within their network where we can install multiple units and decarbonize. And I believe it's somewhere north of 70 units within Tallgrass's network alone. So just think about that. If you take every midstream company in the US and they have something in that order of magnitude of 70 to 400 units per network, I mean, you're talking about tens of thousands of units just in the US midstream alone. So it's significant, right? This becomes now of the order of huge power plants with major CO2 offset. And then we've also manufactured and sold units into the upstream market. We just recently delivered a unit to CNX Resources. that's exploration production company in the United States, and we should be commissioning that unit at a wellhead in the upcoming months.
You mentioned a little bit, but how do you help companies progress towards their ESG goals while ensuring a solid financial returns?
Sure. So the way we've really built the company strategy is without incentives, this technology needs to make sense, right? And if you look at solar panels and where they were 25 years ago, there's a reason why we see solar panels on rooftops today and why we really didn't then. The technology was advancing, but there was a lot of focus on cost over the last, few decades. Um, we have designed our equipment to be simple, to have almost zero operational expense, right? We have this system in a magnetic field. There's no metal to metal contact. There's no lubrication system. There's no cooling system. There's only one moving part. So we have made the system, both from a capital cost standpoint and an operational cost, quite attractive financially. So you provide a nice payback on that equipment. The CFO's happy, and therefore that organization can then go down the path of their decarbonization goals while not disrupting their mission of being a financially sound company, right? People are in business to make money. And if decarbonization becomes too difficult or too much of a financial headwind, it doesn't get adopted. And so our technology enables a low cost solution to decarbonize. The other thing I mentioned, we priced it and developed it without incentives in mind. We have been very fortunate that there are incentives available today. The IRA in the United States, which is applicable to our technology, um, carbon credits in open exchanges like in Europe. Japan is now starting to adopt a carbon trading market. Also very helpful and provide a revenue stream for the electricity coming from our machine. So they produce electricity, they generate this carbon credit, and they can then trade that carbon credit on an open market. So not only are they getting the tax benefits of programs like the IRA and their equivalents in Europe and other parts of the world, they can also trade these credits that are coming out of operating our machines. So we started with a very healthy baseline to decarbonize while still having a strong financial return. And that financial return has just improved since because of everything governments are doing around the world for us.
What's your take on hydrogen?
I believe hydrogen has a place. I believe in the hydrogen economy. I've heard stories that everyone's homes are going to be heated by hydrogen. I think that's far-fetched. I don't think it's going to go all the way there. I think hydrogen will be used for large-scale transportation. I think gas turbines are going to have blends burning hydrogen. I think fuel cells are scalable and can be used in transportation, stationary power. Um, so I'm a believer in hydrogen. I think we need to solve a few things. I think we need to figure out how to transport hydrogen in an efficient manner. We're looking a lot at liquefaction of hydrogen. I'm very interested to see if liquefaction is the solution for transport, or if it's ammonia, or if it's something else. So I think hydrogen has a very bright future, but I think it's early, and that's why from our company's evolution, we said let's take orders from folks that are flowing gas today at scalable levels, right? At the midstream levels, at the upstream levels, help decarbonize today with the technologies that are out there, and make sure we're positioned so that we can grow with hydrogen if it develops the way people are predicting it to develop.
So, what are the goals within the hydrogen industry for you?
From Sapphire's perspective,
Yeah.
so there are some changes we need to make with our machine, both to target hydrogen rich gases or pure hydrogen gases, right? There are some technical challenges, hydrogen embrittlement, hydrogen sulfides. I mean, there are some things that we're managing now. So one goal is to solve all those technical problems, right? We've embarked in some R&D projects to work on those things, as have many others. There are some technologies available, some metallurgy available, others not, right? And so there's some other solutions that need to be invented and need to be strengthened. So that's one strategy or mission for our company. The other one is really identifying key deployment opportunities. We do not want to deploy our technology in in an application that we don't think is really scalable and that will really take off. And so, right now, we have liquefaction as a leading application. It's one that seems to make sense. Expanders have always been used in liquefaction. Making it more small scale and having a generator attached to it seems like a good application. It would mean that decentralized hydrogen would grow, right? And then I'm sure folks that make centralized hydrogen hubs don't want that to happen, right? The large corporations that have been doing this for many, many years are probably thinking more, let's manufacture hydrogen and build a pipeline, just like they have been. So if it goes decentralized and you're producing hydrogen and you're liquefying it in a decentralized manner at truck stops and trains and airports, then, maybe, right? Maybe that's a solution. But really, I'm cautious. I'm cautious of not spending too much energy, corporate energy, on an application that I don't see yet. Right? And so we're doing a lot of R&D projects with different partners. We're looking at things, but we're not all in yet until we have a few applications that we believe are really going to take off. So right now, I think it's liquefaction. I think it's blended hydrogen. So we can install our equipment on the natural gas pipeline, produce clean electricity that drives an electrolyzer, and then that hydrogen gets blended back into the pipeline. Okay, and several gas companies are doing that now around the world, but they're not using our product to do that. They're trying to find other clean energy sources. So one of the ideas is, why don't you use the natural gas that's already flowing, produce clean electricity, run the electrolyzer, and then blend that hydrogen at whatever 5 or to 20% blend rate that you're going to blend, and it is considered clean hydrogen because it was produced with a renewable or with a carbon-free source. So that's something we're looking at.
What's next in terms of your technology development, innovation?
I think it is hydrogen. I think it is more scalable applications in the upstream at the wellheads, whether they're onshore wellheads or offshore wellheads. I think that's a market that I'm quite interested in. And I think there's a lot of pressure globally on production companies to decarbonize, on emission sensing, emission capturing. And this is another way of making that process more efficient and offsetting some of the carbon footprint somewhere else. So I think it's scaling in multiple markets. So we're selling all over the world. We have applications in Asia. We're growing in the United States. We're looking at Canada. So all of these markets are part of the next step, right? That just demonstrating different applications and demonstrating that this is not incentive-based or geography-based. This can work anywhere.
Freddie, thank you for being my guest today.
Thank you, Arnis. Have a wonderful evening.